In this video, I'm going to look at the solving of exponential equations. No calculator will be needed unless you want an approximation. So typically you can solve some exponential equations, and again, an exponential equation is simply the equation that involves an exponential. So let's say the base is a, or whatever you want to call it, and it has a variable exponent, like say a to the x, or a to the 2x, and so forth. So any equation that involves one or more exponential like this is an exponential equation. So typically, if I can get the base the same on both sides, so if on one side I get a base b to some power, let's call it x, and then on the other side I can get the same base b, and let's call whatever the exponent is y, then if the base is the same, the exponents have to be the same. So from this I would conclude that x would have to equal to y. Now when you solve these, x will be some expression involving a variable, or it could be just numbers, and the same sort of thing with y. So not all can be solved like that, but in this particular case, if we look at this, I have 8 to the 3x, I got 16 to the x minus 1, so let me just do this. On the left side, I can write that as 2 to the x, 2 to the third, I should say. And this would have to be a 3 right here. Okay, so 2 to the 3 is 8, and then here, power to a power, you multiply the exponents here, so that would give me a 9x. Okay. And then on the other side I got 16, so I know that 16 is the same thing as 2 to the 4th, so I rewrite the 16 as 2 to the 4th. And then I can write the power as here as x to the minus 1. You can see those are the same thing. Okay. Power to a power, I multiply here, or I could just leave this 2 to the third, 8, and that's 8 to the 3x, same thing here. And here, again, this is 2 to the 4th is 16, and then the power is x minus 1. So then I would simply say, then rewriting this, power to a power, I just write that as 2 to the 9x. On the other side, again, I have power to a power, I would multiply the exponents there. So 4 times x minus 1 would give me 4x. And then 4 times the minus 1 is minus 4. So now here I have the same base. I have the same base. It follows in the exponents have to be equal. So this would be then 9x would have to equal to 4x minus 4. And then solving for x here, subtract 4x from both sides. Here I get 5x over here. So subtracting 4x from both sides, I get 5x is equal to minus 4. And then I want to solve for x, so I divide it by 5. So I get x is equal to minus 4/5. So that's the solution to your equation. Now you could solve the problem using logarithms, taking the log of both sides, if this hadn't worked out, but in this particular case it works out, so I get x is equal to minus 4/5. Okay, so let's clear this. Continue to the next one. Now again, here I have the base is e. So again, I try to see if the same thing will work. So let's say on the left side, I just leave it as e to the minus x squared. And on this side over here, okay, I got e to the x squared. So if I go ahead and perform that operation, this becomes e to the 2x. And then this is times 1 over e to the third. I'm going to rewrite that using negative exponents, e to the minus 3. And then I can go ahead and write this as, again, leave this the way it is, e to the minus x squared. And then here we have the same base, so we can combine those at e to the 2x minus 3. Okay, now I have the same base here. Got the base the same here. So that means the base is the same on both sides. That means the exponents have to be the same. So I'll just write it up here. That means that minus x squared has to equal 2x minus 3. Okay, so now this breaks down then to a quadratic equation. Okay, so quadratics can be solved by factoring. You can use quadratic formula or completing the square. In this case, I'm going to try to see if I can factor this. So I'm going to bring this over to this side, make it positive. It's be x squared plus 2x minus 3. Okay, so again, got the base the same, so I could equate the exponents, and it gives me a quadratic. So again, this is 0 on this side, and then I try to factor the other side. Otherwise, I would have to use a quadratic formula. Okay, so this gives me x plus 3. And the other factor would be x minus 1. Okay, so the product of these two factors is equal to 0. That means that one factor has to be 0, or they're both 0. Okay, so generally we just set each factor equal to 0 and solve. Okay, so if x plus 3 is equal to 0, that means x would have to be negative 3. If x minus 1 is 0, that means x has to be 1. Okay, so my solution then comes out to x equal to negative 3, or x could be 1. Quadratic, I have two solutions here, two distinct solutions. Okay, we'll clear this. Look at the next one. I have e to the 2x plus e to the 2x plus 3e to the x minus 10. Okay. And you should be able to see this as a form of a quadratic. Okay. Because I can write this as e to the x squared plus 3e to the x minus 10. So this is kind of the same thing as having something like x squared plus 3x minus 10. So I'm just going to try to factor this the way it is. One side is 0. So this e to the 2x, that's the same thing as e to the x times e to the x. So that can be factored then as e to the x, e to the x. And then the minus 10 can be factored as a plus 5 and a minus 2. And that should be equal to 0. Okay. So this is kind of just like solving like x squared plus 3x minus 10 is equal to 0. Except in this case, the x is e to the x. So again, we can easily solve for e to the x here, setting each factor equal to 0. So if I set e to the x plus 5 equal to 0, that would tell me that e to the x would have to equal to negative 5. If I set e to the x minus 2 equal to 0, that would tell me that e to the x is equal to 2. Okay, so I get two equations, so I could have two possible solutions, but here you have to just be careful here. E is approximately 2.72, and that's taken to the x power. So there's no way that this is negative. E to the x. Okay? Just like 2 to the x or 2 to the x. No matter what the x is, whether it's positive or negative or 0, e to the x is never going to be negative. So this first equation has no solution. No real solution. That's the empty set. E to the x is positive, and the right side is positive. Okay, so this could have a solution. So one way to solve this one without using the graphing calculator here is to just take the natural log. I would just take the natural log because it makes it easier. You could use base 10, but I would just say the natural log of e to the x is equal to the natural log of 2. And just from the basic idea of logarithms, because this base right here, natural log is e, this is c, and this is c. So if you know your basic properties of logarithms, you know that the left side is just x. And the right side is just natural log of 2. So this is the answer. This is the exact answer. Now, if you want an approximation, if you ask for an approximation, then you can use a calculator. It doesn't have to be a graphing calculator. It could be just a scientific calculator. But here I use the 84 and say, okay, want natural log, there it is, of 2. And I get 0.693. Okay, so if I wanted an approximation, I would say that this is equal to 0.693. Round it out to 3 places, okay, of whatever they tell you. But this right here is your exact answer. So if the instructor asks you for an exact answer, you don't need a calculator on this one. Okay? That's it for the video. Thanks for watching. We'll see you next time, and stay safe.